equations with inequalities, and we're going to answer the question, how can I solve quadratic inequalities? So question 49 says, or is titled, Gold Digger's Gulch. During a field trip to the Minor 49ers amusement park, Alfredo notices that a portion of the Gold Digger's Gulch roller coaster is shaped like a parabola. Near the base of the parabola, the track goes underground into a tunnel. A car on the track speeds towards the tunnel from 300 feet above the ground and then reemerges above the ground 100 feet to the right horizontally. So there's a pretty good graphic of that happening over to the right. So you've got to imagine that underground, it's making that parabola shape. It says, write an equation for the path of the car on the track. Let x be the horizontal distance in feet, and let y equal the height of the car in relation to the ground, also in feet. State an appropriate domain for this situation. All right, so we're going to come up with an equation. One of the terms or factors is going to be x minus 50, and one is going to be x minus 150, because that's where it's coming out here and here. It also has a stretch factor of 1/25. This is going to happen, or what we call the domain, is going to happen between 0 and 200 feet. Okay? Part B says, when is the roller coaster car below the ground? That is, for the values of x in the function is the function negative. Use your equation from part A to write an inequality to represent the situation, then write its solutions as an inequality. So it's the same equation, but instead of having an equal sign, for the parts that are below ground are when it's going to be less than 0. So the only thing that changes is the equal sign changes to the less than, and we say less than 0. Because it'll be below ground, you won't be able to see it. That happens between 50 and 150 feet. So from here to here. Right? Part C. When is the roller coaster above the ground? So this one, we're going to flip that sign to greater than 0. And what are the values? For what values of x is this function positive? When it's between 0 and 50, and 150 and 200, that's going to be the range of those. Part D, we're going to skip and move on to question number 50. Question number 50 says, the operational costs of the Minor 49er amusement parks are $300,000 per day. The business manager for the park uses the function 100 times x times 0.05x plus 5 to project the revenue for a given day if X amount of people visit the amusement park. Okay? So how many people come into the park is going to determine whether or not they make a profit each day. Okay? So if only 10 people come into an amusement park, is it likely they're going to make a profit that day? No. So you want to see how many people they need to have in a park for them to make a profit on any given day. So we're going to subtract $300,000 because that's how much they need to make in a day in order to cover all of their operating costs. They have to give their employees their salary, they have to pay for the electricity, they have to pay for water, the bathrooms and cleaning and all that stuff. Okay? So for what number of visitors will the park lose money? So if it's less than 200 people in that park, they're not going to make any money. They're going to lose money, right? And when is the profit function you wrote in part A? Negative between negative 300 people and 200. We're going to skip part D. Anybody still writing? Yeah? Okay. Fog City. San Francisco is well known for its fog, very thick, low-lying clouds that hide its hills. One foggy day, Penelope is practicing kicking a football. Once she kicks the football so high that it disappears into the fog. The height, h, of the ball in feet can be represented at time, t, in seconds for the equation. And again, they're giving you the equation, negative 16t squared plus 64t. This negative out front makes it open down, right? So when she kicks the ball, it goes up like this, right? And follows that curve. The ball disappears into the fog when it is 40 feet high. Write an inequality that represents the times during which the ball was not visible. Solve the inequality and represent your solution algebraically and on a number line, okay? So you want to take the equation that they give you. So they give you the equation negative 16t squared plus 64t. That's the left side. And the ball disappears when it hits 40 feet. So anything above 40 feet or greater than or equal to 40 feet is where you won't be able to see the ball. It's going to disappear for a few seconds, and then when it starts to come back down on the other side of the parabola, you're going to be able to see the ball again. Okay? So we're going to take that 40 and subtract it, move it over to this side, which puts it in what we call standard form. Once it's in standard form, you can factor it, but this one is not easily factorable, so we're going to do the quadratic formula on it. So you take the coefficient of the squared term, which is negative 16, the coefficient of the x term, in this case they use the variable t, which is fine, which is 64, and the constant term, negative 40. We're going to plug those three numbers into our quadratic formula, which looks like this. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And then remember, when you do this, you get two answers, right? One with adding and one with subtracting. So you punch it once in your calculator with adding, and you get 0.8. You punch it in your calculator again with the subtracting, and you get 3.2. Those are the two places where it disappears into the fog, between 0.8 seconds and between 3.2 seconds. The ball, she kicks the ball, it goes up, it disappears into the clouds, comes back, starts coming back down, reappears, and comes back down to the ground. Between 0.8 seconds and 3.2 seconds. All right? Part B says, how high does Penelope kick the football? And when does it reach its maximum height? Okay? We're going to graph it. I'm going to show you where the vertex is at. And then that will tell us how high it gets and at what time.